For number 1. What does number 1 say we're doing? Macy. We are multiplying. Do I need to KCF if it says to multiply? No. All right. Do I need to fix this problem at all?
Yes.
Okay, let me rephrase that. Do I need to change any of the numbers to a new form?
Yes.
No.
Yes.
No.
Guys, listen to the question. Do I need to change the form of the number? Do I need to change anything to improper or change it to mixed? Do I need to change the form? No. So is there a whole number here? Is there a mixed number here? No. So we're going to leave these just the way they are. In fact, we're just going to go straight in and simplify. All right? So on number 1, what numbers can simplify? Morgan. 7 and 7. And guys, if your numbers match, just mark them out and make a 1. If your numbers match, just mark them out and make a 1. What else can simplify, Danny?
I was just going to ask if you could simplify 7 and 21.
6 and 21, we can. What number can go into 6 and into 21? Chris? 3. So 6 divided by 3 is 2, and 21 divided by 3 is 7. Now, last period, I had someone simplify their 7 and 21. Yeah. Oh, I see what you're saying, Danny. I totally just was like, no, you can't ask that question. Yes. So you could have simplified 7 and 21. That would have given you a 3 down here that you could have then simplified with the 6. Okay. And I had someone last period. They simplified completely differently than I did, but they still got the same answer as me. So try doing that on your paper, Danny. Make sure we get the same answer. So simplify your way. All right. Yes.
Why you have to go opposite ways?
It has to be opposite. Is 7 on the top and 21 on the bottom? So as long as they're opposite, top and bottom, you can simplify them. Even if they're in the same fraction. What you cannot do is if they're bottom and bottom. That's the bad thing. Or top and top. Okay. All right. So now multiplying. On the top, 2 times 1. On the bottom, 1 times 7. So I end up with 2 sevens. Okay, is that what you got? Perfect job. Awesome. All right. Let's look at number 2. Is number 2 a good problem the way it is? No. So what do I need to change this problem to say? Change it up for me. Chrissy, you weren't here yesterday, but you can make these improper. Can you change those for me?
34 over 7.
Okay. 34 over 7 and
17
17 over
over 5.
5. So we did 7 times 4 is 28, plus 6 gives me 34. And then 5 times 3 is 15, plus 2 is 17. Okay? From here, it's a division problem. Can I simplify anything? Why? I want someone to answer. I want to be careful with how you answer. Why can I not simplify? Why can I not simplify? Chandler? We still have to flip. Guys, you can only simplify if it says multiply. Are we okay with that? You can only simplify if it says multiply. All right? So we cannot simplify this. I'm sorry. We cannot simplify this. If it's division, what's our next step going to be? Now that they're improper, what do I need to do next? Ruby-Ann?
Change.
So we're going to keep, change, and flip. If you don't want to write the KCF there, you don't have to, but you do have to show me this step and the next step. So when I keep, change, flip, what's my first fraction going to be? Emma King? 34 over 7. We're changing it to multiply. And Emmanuel, what's my second fraction going to be? 5 over 17. Okay, so now will this fraction simplify? Audrey? Aubrey, sorry. Yes. All right, what can I simplify here? 34 and 17. I can divide these by 17. 17 divided by 17 is? 1. 34 divided by 17 is? 2. Can anything else simplify here? No. All right, so on the top, 2 times 5 is 10, and on the bottom, 7 times 1 is 7. Can I leave that like 10 over 7? No, we're going to need to divide it. 7 will go into 10 how many times? once with how many left over?
3.
3 over
7.
7. Okay. All right. Number 3, is number 3 a good problem the way it is? No, we've got a mixed number, so we need to fix it. What am I going to do? What's the new problem going to say once I fix my mixed number? What's my new problem going to be? Morgan?
6. Yeah, 16.
16 ninths divided by 4 ninths. Okay, perfect. All right. Should I simplify?
No.
Not yet. It still says divide. So we're going to keep, change, flip. I keep it. It is 16 over 9 times 9 over 4. All right, now can I simplify?
Yes.
Yes. Once it says multiply, please simplify. All right, Kinsley?
4 can go into 16.
4 can go into 16 and into 4, so 16 divided by 4 is 4, and 4 divided by 4 is 1. And McKee? 9 and 9. Guys, if my numbers match on the top and bottom, let's just make them 1. Okay, anything else here? Okay, so 1 times 4 is? 1 times 1 is? So what's my answer here? 4. Okay. All right. Guys, looking down here at the bottom, all right, it says that Stacy used 30 blocks to make the tower pictured below. Exactly 1/5 of the blocks will be painted red. What is the total number of blocks that will not be painted red? Please make sure we're doing the ones that will not be painted red. Guys, am I splitting up these blocks? Am I making different towers with the blocks? No, I'm making one tower with the blocks. I'm not splitting anything up. So what operation am I going to be doing here? This whole sheet has multiplying and dividing. Which one would this be?
Multiplying.
We would be multiplying because it says 1/5, not saying 1/5 of blocks, it's saying 1/5 of the blocks, which was mentioned back there at the beginning. Okay? So we would be multiplying here. Now be careful, this 1/5 is talking about the blocks that are red. Do we want to know the ones that are red? No. So you can either change your fraction to be the ones that are not red, or get your answer. If you know that blocks that are red, how would you find the ones that are not red?
Subtract.
You would subtract from that block amount. Okay? All right, you have the rest of those to work on your own. All right, so resuming the homework sheet from tonight, we just did 1, 2, and 3 with last period, so we are going to look at 4, 5, and 6 together in here. Remember, you'll be able to check all of your other answers on the video. Okay, number 4. Is this a good problem written the way it is? No. Raise your hand, guys. I need us to kind of participate appropriately, okay? So let's kind of chill and participate appropriately. Addison.
You have to put 6 over 1.
6 over 1 divided by, and what's that next fraction going to change to? Lex?
5 over 12.
Turner?
12 over 5.
12 over 5. Remember, we need to keep these in separate steps for now. Guys, just this week. Just 1 week. After this week, skip the steps if you want to. Okay, but just this week. This week, give me the improper fractions. Then, in a separate step, keep, change, and flip. All right, so when I keep, change, and flip, now what is my problem going to say, Noah? Yeah, you should probably be looking up at the board and writing down what we have so far, okay? Kai, what is it going to say when I keep, change, flip?
6 over 1 and 5 over 12.
All right, is that the only thing? I feel like we're missing something in the middle there.
And multiply.
And multiply. So we keep it stays the same, we change it to multiplication, we flip the second fraction. Guys, does order matter in division?
Yes.
For dividing? For dividing, order is really, really important. When you do this, you have to keep the first one, change the second one. You can't flip, change, keep. It has to be keep, change, flip. All right, now that it says multiply, I can simplify. What will simplify here? Kate.
6 and 12.
6 and 12. 6 divided by 6 is?
1.
12 divided by 6 is?
2.
Will anything else simplify here?
No.
All right. So on the top, 1 times 5 is? 5, and 1 times 2 is?
2.
Is that a good way to leave my answer? No. How should I write that answer, Lizzie?
2.5.
All right. 2 will go into 5 twice with 1 left over. So that gives me that 2.5, Lizzie said. Okay. Number 5. Is number 5 a good problem the way it's written right now? No. It is not a good problem because we have these mixed numbers. So what can I change number 5 to say? Enrique?
5 over 4 times 11 over 3.
5 over 4 times 11 over 3. 4 times 1 is 4, plus the 1 is 5. And then 3 times 3 is 9, plus the 2 is 11. All right. Do I need to keep change flip? This is already multiply, so we do not keep change flip. That's only if it says divide. So, am I ready to simplify?
No.
We are ready to simplify because it says multiply. Now, is there anything here that will simplify?
No.
No. So do you see the two differences in those questions? Am I ready to? Yes. Can it? No. Do you see something, Charlie? Okay. All right. So we cannot simplify this. So on the top, 5 times 11 is? 55. On the bottom, 12. All right. So this one, I'm going to kind of write out my math to do my division. All right. I know how many times 12 will go into 55. How many is that going to give me? 4. All right. And 4 times 12 is? 48. Because of this subtraction, some of us are really good at this in our head. I prefer to write it out just to make sure I don't make any silly mistakes because I'm really good at doing that. So, 55 minus 48, you can probably subtract that in your head, or we can borrow and make it a 4, and 15 minus 8? 7. So I end up with 7 left over. What does it go on top of? 12. So I get 4 and 7 twelfths. Okay, so you'll notice, guys, you have division problems like number 4. You also have multiplication problems. So they're mixed up here. All right, number 6. Is this a good problem? No. Fix this problem for me. Noah?
8, 15, and 3, 1.
8 over 15 times 3 over 1. Do I need to keep change flip?
No.
No. Can I simplify?
Yes.
Vanessa, what will simplify? 3 and 15. So 3 will go into 15. How many times? 5. And 3 will go into 3? All right, so on the top, 8 times 1.
8.
On the bottom, 5 times 1.
5.
And we get 1 and
3/5.
3/5. Okay, so 5 goes into 8 once with 3 left over. All right. All right, so resuming the recording, we are doing 7, 8, and 9 in this class. So on number 7, is this a good problem the way it is? Jake?
No.
No. How do I need to write it?
So you're going to do 4 over 1 times 5 ninths.
4 over 1 times 5 ninths. Is there anything else wrong with that?
No.
No. All right, do I need to keep change flip?
No.
No. This says to multiply, so we're ready to simplify. Okay, it says to multiply, so we're ready to simplify. All right. Can anything simplify? No. All right, so what do I get when I multiply here, Blake?
20 over 9.
20 over 9. Can I leave it like that?
No.
No. How many times will 9 go into 20? Like
2.
2 times.
Will be 2 out of 9 left.
Yeah. So 19 will go into 20 twice. That gives me 18. So I have 2 more left over. 19, 20 over 9. Okay. Number 8. Number 8. Is there anything wrong with this problem? Joel? No. This problem's fine just the way it is. And I like her, guys. I didn't ask, do I need to simplify? I asked, is there anything wrong with it? Okay. This problem is fine just the way it is. But it does say to multiply, so we can simplify. Guys, please remember, you can only simplify if it says multiply. All right, what can I simplify on number 8, Joel?
By
4, what can divide by 4?
8 can divide by 4 2 times,
Mhm.
and 12 can divide by 4 3 times.
Perfect. Could you have done 12 and 15?
No.
Yeah, what can go into 12 and into 15?
3.
3. So you can do 12 and 15 as long as it's top and bottom. You can't do 2 tops or 2 bottoms, okay? But we could have done 12 and 15. I'm going to do the 8 and 12. So 8 divided by 4 is 2, and 12 divided by 4 is 3. We could have done that to the 12 and 15, though, just dividing by 3. All right, do y'all see anything else that'll simplify? Lily?
The 3 and the 15.
The 3 and the 15. What can divide those? 3. 3 divided by 3 is? 15 divided by 3 is? Okay, anything else there? So on the top, 1 times 7. 7 and 2 times 5? 10. So that's my answer. I don't even have to make it a mixed number because it's just a regular, plain old Jane, good looking fraction. Okay, number 9, is that a good problem? No. What do I need to do to that problem? Looking for a new hand. Kiana? Well, I need to change the mixed numbers to improper. Mm-hmm. So what is my first fraction going to say?
It's going to say 16 over 5.
16 over 5, because we did 5 times 3 is 15, plus 1 is 16. We're not changing anything else, so that's still a division symbol. What's my next fraction going to say, Kiana?
It's going to say
16 over 9. So 9 times 1 is 9, plus 7 is 16 over 9. Okay? Can I simplify? Blake?
No.
Why not?
Because you can't simplify 2 numbers on the same line.
Okay, we can't simplify 2 numbers on the same line, but that's not the reason that I can't simplify here. Why can I not simplify here? Owen? We have to keep change flip. You can only simplify if it says multiply. Does this say multiply? No. So can I simplify? No. All right, so we're going to keep change and flip like Owen said. So Owen, what's my new problem going to say?
16 over 5 times 9 over 16.
Perfect. 16 over 5 times 9 over 16. Now, can I simplify?
Yes.
All right, Ada, what can simplify here? All right, and remember, if they're the same number, we can just mark them out and make them ones. All right, anything else to simplify? No? So on the top I get? On the bottom we get? 5. Can I leave it as 9 over 5? No. 5 will go into 9? One time with 4 left over, and that's going to still be over 5. Okay. All right. So we are looking at number 10 in here. We're going to do this bottom piece. All right. On number 10, is that a good problem the way it's written right now? No. So, Noah, you were here when we multiplied. I know you weren't here yesterday. But if this was a multiplication problem, how would I have to change it? Noah, got it. Perfect. And that gives me 14 plus the 1. So I have 15 over 2. I'm going to keep that division symbol right there. And what would I do to the 3? And make it 3 over 1. Okay, perfect. So even not being here yesterday, Noah already knows what's up. All right. Now the difference in yesterday, or last week and yesterday. Once we get here, it's a division problem, and we fixed it. Now it looks good. We can work it out. But we need to do one step. So this is the big thing that we learned yesterday, Noah. This is the one step that you have to do on a division problem that's different. What is that going to be, Braden Bolgar?
15.
What's it called? KCF. We have to keep change and flip, because what's going to happen is now, what's my problem going to say, Braden? 15 over 2. So you can see we kept it. It didn't change. Then it says C for change. What's going to change? It's going to be times now, because we know how to times. And then it says to flip it, what's that fraction going to be? 1/3. All right? So Noah, this is the big thing that's different. All All right, and you only do this when it's division. All right, so now that I've done keep, change, flip, if it says multiply, I should simplify. That's our rule. Can I simplify here when it's division? No. Once it says multiply, you can simplify. All right, so Braden, what can simplify here?
The 3 and the 15.
The 3 and the 15. So 3 divided by 3 is? 15 divided by 3 is?
5.
All right, can anything else simplify here? So on the top, 5 times 1 is? 2 times 1 is? 2. Okay, can I leave it as 5 over 2?
No.
How many times will 2 go into 5? Try it.
2 times.
2 times,
Just 4.
which is 4. So how many are left over?
1/5.
1. Thank you, Jakaria. Carrie, next time, wait until I call on you, okay?
Here.
All right. Okay, so I get 2.5. All right, now on number 11, what do you notice? Number 11, is it still division? No, number 11 is multiplication. So you'll notice on this worksheet, it's all mixed up. We got dividing on there, we got multiplying on there, and they are mixed together. All right, so number 11 is multiplication. Is this a good multiplication problem? No. Jessica, what do I need to do? We have to change the 3 and 4 fifths. So I'm going to do my 5 times 3, which gives me what, Jessica?
15.
Plus the 4 over 5. Times, what's my other fraction going to change to? Gabby? 8 times 2 gives me? You're good, Gabby. So I'm looking at that second one. 8 times 2, what do I get? 16. Okay. And then plus the 3 gives me 19 over 8. So it looks kind of weird because I have 19s on both of them. That's okay. All right, so double checking my math. 5 times 3 is 15 plus 4. That's definitely 19. 2 times 8 is 16 plus 3 is 19. We've done this correctly, right? And the reason I'm double checking, guys, is can I simplify? Oh, there's nothing here that's going to simplify. Can I keep, change, flip? No, this is multiplication. We can't, we're kind of stuck with this. So as bad as these numbers look, we're going to have to work with them. All right, so I need to know what 19 times 19 is. So you can go over to a side of your paper. You can flip it over on the back if you want. All right, I'm just going to go over here right next to it. 19 times 19. Okay, so 9 times 9 is? 81. Carry my 8. 9 times 1 is? 9 times 1 is? 9. Plus the 8 is? 17. All right, put my 0 as a placeholder. 9 times 1? And 1 times 1. So adding that up, I get 1. 7 plus 9 is? 16. 1, 1, and 1 is? So for the top, I have 361 over 40. Okay, can I leave it like that, Mary Webb?
No, you have to divide it.
I have to divide it. So we're going to do 40 divided into 361. How many times will 40 go into 3? None. So I'm going to move over to the 6. How many times will 40 go into 36? None. How many times will 40 go into 361? So what's a good number that we can try? Carrie? 2. So let's come over here. So I'm going to do 40 times 2. 2 times 0 is? 0. 2 times 4 is? 8. So I got 80. Do you think I can get closer to 361? Probably so. All right. What would you like to try, Braden? Okay, so let's try 6. 40 times 6. 6 times 0 is? 0. 6 times 4 is? 24. Hey guys, do you notice that all that's happening is I'm multiplying my 4 and adding a 0? So what do you think would be a good number to multiply times 4 that's going to get me close to 36? Frank? 9. So 40 times 9, 9 times 0 is 0. 9 times 4 is? Oh, 360. That's pretty much as close as I can get, isn't it? So I'm going to put a 9 on top. 9 times 40 was 360. How many are left over? 1. So I get 9 and 1 over 40. And I'm going to write that bigger right here. 9 and 1 over 40. Okay? All right? Questions about that? So guys, if you have a number like this where it ends in a 0, really you're just multiplying the first thing and adding the 0. That'll make it easier to pick your number. All right, number 12. Is number 12 a good problem the way it is right now, Mason? Does number 12 look good? The way it is? No. Can I have these big numbers in front of my fractions? No. All right, Christian, can you change the first fraction for me? What's that first fraction going to be? 33 over? 3. Close. 5. Yeah, make sure we keep that denominator. Divided by, what's my second fraction going to be, Keegan? 13 over 5, because we did 5 times 2 is 10, plus 3, 13. Okay, can I simplify right now? No, remember it has to say multiply. So what am I going to do next for division? I know you weren't here, but what are my letters that I need to do next? Yeah, K? K, C, F. All right? No, I know you weren't here, so I'm kind of quizzing you. All right? So if you don't know it, it's okay. You can let me know. You haven't gotten to practice. Do you remember what the K stands for? So what's my first fraction going to be? 33/5. We keep it just the way it is. What does the C mean? Change it to multiplication, and then the F, flip, and what's my second fraction going to be? 5/13. Perfect job, and he wasn't even here. Excellent. Thank you. Okay, what can I simplify? Now it says multiply, so we're going to simplify. Kelsey. 5 and 5. So guys, if they match, I can make them a 1. Okay? 13 and 33, can those simplify? No. No. All right, so when I multiply, I get 33 on top, 13 on the bottom. Is that a good answer? No. So if you want to flip it over on the back, you can. We're doing 13 into 33. How many times do you think 13 will go into 33? Peyton? Twice. 2 times 13 gives me 26. When I subtract that, can I do 3 minus 6? So I'm going to borrow, so that becomes a 2. So now it's 13 minus 6. 13 minus 7. Thank you. So I end up with 2 and 7 over 7 over 13. 2 and 7 over 13. All right. I want us to look at the word problem. All right, we had a bunch of stuff on this worksheet. There's multiplying, there's dividing, so I've got to be able to decide what to do on the word problem, okay? On the word problem, it says, Stacy used 30 blocks to make the tower picture below. So here's my tower of blocks. Exactly 1/5 of the blocks are going to be red. We want to know the total number that will not be red. Now, before we worry about what's red, what's not red, we need to decide, am I multiplying or am I dividing on this?
She really wants ink, so she'll do work.
Okay, thank you. All right. Am I multiplying or am I dividing here? What do you think, Braden? Okay, why do you think we're multiplying?
Because it's asking.
Okay, so it's asking for one whole amount. Do y'all agree with that? I like the way that you worded that. That was really good. I've had trouble all day figuring out how to put this into words. All right, so guys, it's just asking for one thing. These are red. These are not red. All right, so are we going to say, here's a tower, here's a tower, here's a tower, here's a tower? Am I splitting my tower up? No, I'm just saying, hey, this piece of the tower is red, this piece is not. If I was creating a bunch of pieces, that would be division. Am I creating a bunch of pieces? No, I'm just saying, hey, this part is red, this part is not. Do y'all understand what Braden's saying about, hey, it's just asking for one whole amount? It's not asking for a bunch of different pieces of pipe or a bunch of different batches of pancakes. That's what we talked about yesterday. All right. So we are going to be doing multiplication. Excellent job, Braden. All right. So I'm going to multiply. I have 30 blocks, and I'm going to multiply that times 1/5. Is that a good problem the way I've written it right now? No. What do I need to do to my 30, Easton?
Put a 1 underneath.
Put a 1 underneath. So I have 30 over 1 times 1 over 5. Can I simplify this? Yes. What can simplify here, Morgan?
30 and 5.
30 and 5. My 30 is going to become
8.
6, and 5 becomes 1. Okay, so now on the top, 6 times 1. 1 times 1. So that equals 6 blocks, right? Now here's my question. The 1/5 was talking about the ones that will be red. So guys, these 6 blocks are 6 red blocks. Do y'all see where I got that from?
Yes.
What does it ask me about?
Not
Which ones will not be red? Are 6 ones not red?
no.
6 are red. So what am I going to do to figure that out, Keegan? We're going to take my 30 blocks, and I'm going to take away the 6 that are red. So 30 minus 6 is 24. So there are 24 blocks that are not red. And that's what the question is actually asking.